Welcome to Lesson 3.6, Markups and Markdowns. Our focus questions today: when are percent markups and percent markdowns used? How are they similar? And how are they different? So let's start by looking at what a markup is. A markup is the amount of increase from the cost to the selling price. So our markup is equal to our selling price minus the cost. So the cost of this shirt is $16, but it's going to be sold for $28. So our markup is 28 minus 16. And just so you know, the cost is how much the store would pay for the shirt. The selling price is how much the store is going to sell the shirt to you. So to find our percent increase, remember we did percent increase equals the amount of change over the original quantity. Well, right now our markup is the amount of change, okay? And the original quantity is the cost that the seller paid to buy the shirt. So instead of the percent increase, it's known as a percent markup. It's going to be important to write these formulas down as we go to help us to keep everything straight in our head. So for this example, the difference, 28 minus 16, was 12, over the original cost was 16. When I simplify that fraction, I get 3/4, which we know is 75%. So there is a 75% markup on the shirt. So let's look at some examples. What is the percent markup for each item? Round to the nearest percent. So the first thing we have to do, and we've got to write these steps, and you have a touch more room off to the side. So I'm going to write them, and then I'm going to erase them. Actually, I'll write them down here for you guys. First step, find the markup. And remember, the markup is the selling price minus the cost. Then I plug it into the formula. And the formula we're using is percent markup equals markup over cost. And then the last thing I do is convert to a percent. So I hope you wrote these up off to the side where you're going to have more room. So let's find the percent markup for the notebook. So I'm going to label it NB for notebook. Okay, so my formula is percent markup equals my markup over my cost. So, what is the difference in prices? $1.25. And what was the original cost? Just 25 cents. So when I do the arithmetic on this, I get 125 over 25. I just multiply the numerator and the denominator by 100. And to get this to have a denominator of 100, that's what I need for a percent. I've got to multiply the numerator and the denominator by 4, which gives me 500 over 100, which means this was marked up 500%. Okay, so that was for the notebook. Let's look for the bicycle. I'm going to label it bike. I'm going to write my formula down, percent markup equals markup over cost. So the markup, 300 minus 180 was a markup of $120. And the cost was 180. When I simplify that, it's 2/3. You should be familiar with knowing 2/3 is 67%. If you weren't, do 2 divided by 3, you get 0.6666 repeating, which is 67%. Now let's look at the car. Percent markup equals markup over cost. So my markup, $12,000 minus $8,000 is $4,000 over the cost of $8,000. We know that simplifies to 1/2, which we all know is 50%. Okay? So that's a basic example of percent markup. Let's make it a touch more difficult. Airlines usually increase the price of their plane tickets as the day of the flight gets closer. What is the percent what is the percent markup for the plane ticket below? So let's write our formula. Percent markup equals the markup over the cost. We are looking for the percent markup, okay? Not a problem. So, we know the markup is 550 minus 310, which is 240, over my original cost of 310. When I do the simplification, this is approximately 0.77. Which we can convert to 77%. So the percent markup on the plane ticket is 77%. Concert halls change the price for concert tickets depending on the performer. What is the selling price for the concert ticket below? So we're looking for the selling price. Okay, and we haven't talked much about selling price since the beginning, but we do know this formula, the percent markup equals the markup over the cost. Okay, we're looking for the selling price. They've given me the percent markup is 90%, so 90 over 100. We need to find the markup price, so I'm going to put an X in there, and we know the base cost is 20. So now I have a proportion. I can cross multiply, but first I see right away, I can simplify here and make that 9/10. It's going to make it a little bit easier to work with when I go to do my math. So when I cross multiply, 10 times X is 10X. 9 times 20 is 180. Divide both sides by 10. X equals 18. So 18 is my markup. Okay. Let's remember the selling price equals the cost plus the markup. I'm looking for the selling price. My cost from the beginning was $20. And we just calculated the markup to be $18. So the selling price is $38. You have to read the question carefully. You have to remember the formulas, and you have to think logically about how it's going to work. The selling price is the cost that they paid plus the markup. Now, going in the opposite direction, we have a markdown, okay? The markdown is the amount of decrease from the selling price, this is a little bit different, down to the sale price. So markdown is selling price minus the sale price. Remember, our percent decrease formula was the amount of change over the original quantity. Okay, so my percent markdown, percent decrease to percent markdown, the amount of change is now called your markdown, which we can get from up here, over the original selling price. In this example, the markdown, 28 minus 21, gave me a markdown of 7. Over the selling price of $28, when I simplify that, I get 1/4, which is 25%. So this shirt was marked down 25%. Five years ago, a furniture store bought sofas for $835 each. What is the greatest whole percent that the manager can decrease the price of the sofa without losing money? Okay, so we know the original cost. They paid $835. We also know the selling price is $1,599. What do we need? We want to look for the greatest whole percent markdown. But we don't want to lose money, so W/L without losing money. Okay? So my plan, I'm going to find the greatest markdown. And then I'm going to find the greatest percent markdown possible. Okay, so let's find the greatest markdown first. Remember, the markdown is the selling price minus the cost. So the selling price was $15.99. The cost was $835. When I do the math, I get $764. So they can sell those sofas for $764 and still break even or not lose any money. Okay? So I'm going to extend my page here. So my percent markdown equals my markdown over my selling price. So my markdown was $764 over my selling price of $1,599. I have to extend my page again. When I do that calculation, I get 0.478. If I convert that to a percent, it's 47.8%. However, they want it to the nearest whole percent. In this case, I have to round down. Because if I round up, that means I'm going to take more of a price off, and it's going to end up making my selling price below what they paid for it, make it below $835, and they would lose money. So this is why we have to keep it at 47%. This is an excellent situation of making sure you're paying attention and reading carefully. Okay? Here's an example of markdown, and it's pretty straightforward. So I want you to try it, and then I want you to come back. Okay, nice and straightforward. I wrote my formula, I substituted in, the markdown was $50 over the sale price, or the selling price, excuse me, of $250, which simplified to 1/5. And we know 1/5 is 20%. Okay, 2 more slides. Relaxed Yoga Store buys yoga mats for $15 each. The store has a sale the following week. Does the store still make a profit on each mat during the sale? And if so, how much of a profit? So we know, here's the cost, $15. We know the sale price is $38.99. I'm going to label it FP. And the percent markdown is 20%. Okay. Let's write down our formula. Percent markdown equals markdown over the selling price. Okay. We have to find the markdown. We know the cost. That's not one of the things in my formula. But I do know the percent markdown is 20 over 100. The markdown itself I'm going to call X, and the sale price is $38.99. A little simplification here, and when I simplify this, I get 10X equals $77.98. And then when I divide, I get $7.98, which we know is really $7.80. Okay. Remember, my sale price equals my selling price minus my markdown. So my sale price equals my selling price of $38.99 minus $7.80. So the sale price works out to be $31.19. Did I answer their question? Does the store still make a profit? Yes, the store makes a profit. The profit is $31.19 minus 15 is $16.19. The profit is how much I sold it for minus how much I paid for it to buy the cost. So I'm still making $16.19 on each yoga mat. I want you to look at this here. The Yoga Relax store negotiates to buy even more yoga mats from their sellers. If he can give them 35% off the original $15, if the seller gets the mats for $8.50, would he still make a profit on each mat with this deal? If so, how much of a profit? I want you to think about this one. I want you to try it, and we're going to discuss it tomorrow. Have a great night.